This video is going to be about how Newton's second law relates to momentum. So we'll start out with an object. So our object is traveling with an initial velocity of u, and it's being accelerated by a force F. We're going to start from time being equal to 0 right at the beginning. And because we're applying a force, and it's an unbalanced force, our object is going to be accelerating over the distance that we apply the force, so that the object at the end now has a different final velocity due to applying the force over that distance. And at the end, time will be equal to our total time. So the initial momentum of our object is equal to its mass times its initial velocity. And the final momentum for our object is equal to the object's mass, remember the mass wouldn't change over this, times its final velocity. So if we calculate the impulse, the final momentum minus the initial momentum, and how that changed over the time period, t, we can factor out the mass, because it's the same throughout the entire happening. We just get final velocity minus initial velocity divided by time. So I get mass times our change in velocity over our change in time. Our change in velocity over change in time is an acceleration, so I get ma, mass times acceleration. If you remember Newton's second law, force is equal to mass times acceleration. So all of this is equal to mass times acceleration. And I'm going to say this is the average force applied over that distance, because if I had the force changing, it'd be a little bit different. So it's the average force over that distance. Okay, and mv minus mu, if you'll remember, is impulse, so delta p over time. So I end up with the average force is equal to our change in momentum per time. And I can rearrange this so it appears as it does in your data book. The average force times the change in time is equal to impulse. All right, that's the end.